Across the hot, dusty prairies of Texas, sleek tanks hunt out their quarry. Tankers of the United States Army's 1st Cavalry Division wage mock combat using one of NATO's newest and finest tanks, the M1 Abrams. The Abrams is named after General Creighton Abrams. Although Abrams is best known as the commander of the United States Army forces during the Vietnam War, he is a legendary figure amongst the American tankers for his hard-charging leadership of the 37th Tank Battalion in World War II. American tanks have changed greatly since Creighton Abrams' days. The M4 Sherman tank, like the one commanded by Abrams in World War II, was armed with a 75mm gun. Today's M1A1 is armed with a 120mm gun that is 3 times as powerful. The Sherman was protected by a bit more than 2 inches of steel armor. The advanced Chobham armor of the M1A1 offers protection 12 times as great. The M4 was a fast tank for its day, capable of 25 miles per hour on roads. The M1 Abrams is nearly twice as fast, even in rough terrain.
The increased speed causes you to be able to do a lot more things than you normally could with the slower M60 series. And plus it opens up some terrain to you that you can use as high-speed avenues of approach, which you didn't have before.
Development of the M1 began in the early 1970s to replace the older M60 series of tanks. The lessons of the 1973 Mideast War suggested that more attention had to be paid to the threat of guided anti-tank missiles. The Abrams design placed protection as a major priority.
It should be mentioned that from the outset of the design program for the M1, the user, the soldier, was at the center of our thoughts. That was manifested not only in trying to make crew survivability the key new characteristic of the tank, but also to make the tank fightable.
Chobham armor provided a major advance in defeating the missile threat and gives the Abrams its distinctively slab-sided appearance. The greatest risk to the crew was the ammunition carried in the tank. On the Abrams, the ammunition was positioned in a special compartment at the rear of the turret. It was separated from the crew compartment by special blast doors. If the ammunition is ignited by an enemy projectile, the explosion is vented upwards, away from the crew through special blowout panels. This once secret test footage is a remarkable demonstration of this feature. In spite of the conflagration in the rear of the turret, the blast doors protect the crew from the fire. Another key aspect of the M1's design was its weapon system. The main gun itself is only one element of the overall weapon system. Tanks appear to be crude cast-iron monsters, but their insides are crammed with high-tech, solid-state electronics designed to operate in the gritty environment of the modern battlefield. Previous generations of tanks had to stop to fire. The M1 and other modern NATO tanks can fire on the move. The turret stabilization system keeps the gun aimed at the same point, no matter how much the tank is jostled around by the rough terrain. The Abrams Advanced Electronic Gunfire Control System gives it incredible accuracy at ranges over 1 mile. A muzzle reference system measures barrel warp caused by the heat of repeated firings. A wind sensor checks for crosswinds that would cause a projectile to go astray. A laser rangefinder accurately measures the distance to the target to within inches to ensure precise aiming.
We have a laser rangefinder system that allows us to be able to send out a laser beam that goes out and hits the target, bounces back, and determines the range based on the time of travel for the laser.
The data from the tank's advanced sensors are rapidly absorbed by a ballistic computer with little attention from the gunner. The Canadian Army Trophy Shoot is held every 2 years to test the abilities of NATO tank crewmen. In 1987, the M1 demonstrated the effectiveness of its advanced fire control system by beating all previous records for rapidly engaging and destroying its targets. The speeds of kills on a modern battlefield are going to be totally different than they used to be, where you would shoot multiple times and not get hits. And nowadays,
You have over a 90% probability of hit even while moving.
The advanced electronics are easier to use than the mechanical systems used in previous generations of tanks. Tank crews are now expected to hit their targets much more quickly and with greater accuracy than in the older generations of tanks.
The target will come up and stay exposed, depending what type of engagement it is, anywhere from 40 to 50 seconds. And then they will be expected to kill it within 12 seconds, okay, from the time that they actually initiate the engagement to the time that they kill the target. And within that, you have about 5 seconds reload time for the crew in case they have to fire a second round. But normally we get them on the first round.
The new NATO tanks also have an advanced sighting system fitted with a thermal imager. The thermal imager senses the minute temperature differences between man-made objects, like tanks, and the natural background. This enables them to locate and identify enemy tanks at night or in the daytime when they're hidden by smoke or camouflage.
Very improved system where it allows us to have basically daylight 24 hours a day. And we have eyes at night now that can see without the use of any other devices, i.e. IR searchlights, items like that.
Since World War II, tank crews have dropped in size from 5 men to 4.
The M1 is equipped with a 4-man crew. We have a driver. His basic job is to seek positions. That's in the process of handling the driving portion. And we have the gunner. He's to identify and acquire targets and fire them as well. And we have the loader. He basically take care of the aerial watch and also the rear section of the tank. And myself, I'm the tank commander. I pretty much keep control and overwatch over each other position.
As in the case of Britain, American companies have developed light tanks suitable for export. One of the more successful has been the Cadillac Gauge Stingray. The Stingray is armed with a 105mm gun, but it is more lightly armored than the Abrams. The first army to adopt the Stingray was Thailand. France has long been one of the pioneers in tank design. The Renault FT-17 tank was the first true modern tank, with its main weapon located in a fully traversable turret. French tank designers are continuing this tradition with the development of the new AMX Leclerc tank. The AMX Leclerc is named in honor of Marshal Philippe Leclerc, who led the 2nd Armored Division in the liberation of Paris in 1944. The AMX Leclerc is in final development and will enter service in the early 1990s. As modern main battle tanks increase in complexity, their design becomes more protracted and expensive. In the early stages of design, a variety of concepts is studied. The AMX Leclerc designers investigated a number of novel turret and gun configurations. They settled on a conventional turret, but with many advances in gunfire control systems. We spoke to one of its chief engineers to learn more about the features it will include.
La puissance de feu d'un matériel dépend bien entendu de son armement principal.
The firepower of a vehicle depends, of course, on its main armament and on the fire controls which direct the main armament. In the case of the Leclerc, we have adopted a high-performance automatic fire control system integrated with an electric turret drive, which gives the vehicle a high degree of accuracy, which is quite remarkable.
Si bien que la fonction de tir en marche sur la MX Leclerc devient véritablement.
In the case of firing while moving, it's a straightforward matter with the AMX Leclerc, which was not the case on tanks a decade ago. On tanks of the preceding generation, firing on the move required careful attention, and the performance was poorer than one found in the case of firing from the halt.
Aux performances que l'on trouve pour un tir à l'arrêt.
Battle tanks are becoming increasingly computerized to assist their crews in combat. The AMX Leclerc is the first tank to be built around a centralized digital electronics architecture. Tank crews no longer will communicate only by voice over radio, but will exchange critical information through the data systems.
L'AMX Leclerc, par son architecture numérique, les moyens dont il dispose, est en liaison.
The AMX Leclerc, with its digital electronics architecture, is in constant communication with the other armored vehicles moving along with it, whether battle tanks or command armored vehicles. There is data and information centralization aboard each vehicle.
Repose sur l'utilisation d'un bus qui parcourt l'ensemble du char.
Because of the centralized data bus functioning inside, the digital computer architecture centralizes and disseminates the data around the vehicle. This data is coded and can be used by other vehicles. So at any moment, in any location, you know with considerable precision where the vehicle is located, how much fuel it has, how many rounds of ammunition, and so on. The availability of this data permits operations in real time and the best possible employment of the full capacity of the tank in its tactics when equipped like this.
There have been so many advances in tank armor over the past decade that armor packages become outdated, sometimes in less than 5 years. The AMX Leclerc circumvents this problem by using modular armor packages which can be replaced by updated packages when new technology arrives. One of the key differences between the Leclerc and the current NATO tanks is the introduction of an automatic loading system to replace the human loader. With the conceptual design completed, the fabrication of testbed vehicles begins. These are automotive testbed vehicles used to examine the engine and suspension of the vehicle. The turret is not fitted, and instead, special instrumentation is used in its place to monitor the performance of the vehicle. Turret subsystems are examined separately. Finally, a testbed demonstrator is assembled to examine the interaction of all the components. Once problems are resolved, the production vehicle begins to take shape. The AMX Leclerc contains so many secret features that this video of it has certain details electronically obscured. The French Army is confident that its new main battle tank will enhance France's reputation for innovation in tank design. The still of an early December morning along the inter-German border is disturbed by the growl of tank diesels. A German panzer battalion churns the fresh snow in a sleepy pine forest. From the woods appears a platoon of one of NATO's most modern battle tanks, the vaunted Leopard 2. With the harvest gathered and the fields bare, the modern German army, the Bundeswehr, exercises its armored shield. Tanks were the spearhead of the German blitzkrieg in World War II. The legendary Tiger and Panther were among the most powerful tanks to roam the European battlefields during the final years of the war. Today, they stand as silent reminders of the great armored clashes like Kursk, Normandy, and the Battle of the Bulge. Their place has been taken in the modern Bundeswehr by tanks of the Leopard family, the Leopard 1 and the Leopard 2. The Leopard 1 was the first German tank built after the Second World War. It entered service with the Bundeswehr in 1965. Compared to its wartime antecedents, even the monstrous Royal Tiger, it is much better armed. The Leopard 1's main weapon is the standard NATO rifled 105mm gun. It is capable of hitting enemy tanks at ranges of over 1.5 miles. The Leopard 1 is considerably more mobile than the tanks of World War II, with road speeds up to 35 miles per hour. This highly regarded design is the most widely distributed tank type in NATO service, with over 4,000 produced. The Leopard 1 also forms the basis for the Gepard, an anti-aircraft vehicle armed with a radar-directed twin 35mm cannon system. In the 1970s, the German army began development of a new generation tank called the Leopard 2. Though sharing a common name with its predecessor, the Leopard 2 is in fact a whole new design. Like the M1 Abrams and the Challenger, the Leopard 2 is protected by a thick hide of advanced armor. Its frontal area is nearly impervious to the deadly threat of anti-tank guided missiles. A 120mm smoothbore gun forms the sharp teeth of the Leopard 2. This gun spits out a 20-pound metal dart projectile at speeds of over 1 mile a second. This same gun was later adopted on the American M1A1 Abrams tank. Precision is ensured by a laser rangefinder. To keep the gun pointed accurately during high-speed travel, it is stabilized by a high-performance system. The effectiveness of this sophisticated network of gun and sensors has been demonstrated time and time again by success at the Canadian Army Trophy Shoot. This competition pits NATO's best tank crews against a challenging array of targets. Dutch and German Leopard 2 units have often emerged on top. The Leopard 2's rough exterior appearance belies its internal complexity. The turret is manned by 3 crewmen. The loader is responsible for handling the tank's ammunition. The gunner aims the 120mm gun and operates the sophisticated computer-aided fire controls. The commander acquires targets and directs the rest of the crew in their duties. In spite of the technical improvements of modern tanks, the life of a tank crewman is arduous. There is ammunition to be loaded, and there are a host of other chores to keep a sophisticated machine like the Leopard 2 in good operating condition. Tanks are expensive to operate in peacetime. A tank will wear out a set of tracks every 2,000 miles, and they cost over $50,000 for a new set. Electronic simulators can help reduce the cost of training of tank crews by as much as 60%. The Leopard series uses a simulator to train new drivers. Driving a 65-ton tank at 40 miles per hour requires special skills. The simulator is linked to a scale terrain model, and the computer provides the trainee with a realistic image of the countryside. Future systems will use computer-generated images. Once the driver completes basic training on the simulator, he transfers to special training tanks for hands-on experience. Special training tanks reduce the wear and tear on actual combat tanks and are less expensive to operate. The new generation of NATO battle tanks is the fastest on record. High combat speeds make the vehicles difficult to hit during fighting. The Leopard 2's 1,500 horsepower diesel engine gives the Leopard 2 very high cross-country speeds, up to 45 miles per hour. Its torsion bar suspension dampens the jostling of rough terrain. Modern tanks are too heavy to be made amphibious, so rivers are a major obstruction to tank movement. To circumvent this problem, the Leopard tanks are designed to snorkel underwater. The crew seals the vehicle, then employs a special tube device to provide air to the engine and crew. The NATO battle tank is an awesome combination of firepower, armored protection, and cross-country mobility. The tank remains the central element in all armies, but nowhere more so than on the plains of Central Europe. These weapons form an important part of NATO's deterrent strategy, crucial to maintaining a tense but lasting peace in Europe. The sleek shape of the B-1B is a remarkable contrast to its predecessor, the B-52 bomber. Flying the B-1B is also very different.
Although the B-1 is a 470,000-pound big bomber, it handles and flies more like a fighter aircraft. The cockpit has sticks in it. The windows are big, large windows. Visibility is excellent.
Unlike some of the other large aircraft, the controls are identical on each side of the aircraft. A B-52, the aircraft commander had very different and distinct duties from the co-pilot. In this plane, it's not really designed that way. It's designed that either pilot can fly the aircraft from either seat. It's again, just a mirror image. The duties and the tasks that are associated with flying a low-altitude mission at 400 or 500 feet and 500 or 600 knots, one pilot needs to be outside looking and clearing for other obstacles, birds, threats, and the other pilot can monitor the systems inside, make sure that the terrain following system and the engines, things like that, are performing as specified.
Pilots trained to fly the B-1B in a flight simulator, which is an identical replica of the real cockpit. Major Larkin explains the flight controls.
This is a B-1B simulated cockpit. First thing you notice when you get into a cockpit of a B-1 is it looks more like a fighter than it does a heavy bomber. We have the airplane has got sticks to fly with. Each position, the co-pilot and pilot have a stick. Each pilot has a set of throttles, and then each pilot has a wing sweep control, so the aircraft is just as easy to fly from the right seat as it is the left seat. The cockpit itself is fairly modern, even by today's standards.
The B-1B was designed to scoot under enemy radars at very low altitude. Flying so close to the ground at such high speeds can be risky. But the B-1B has the most sophisticated terrain-following system ever developed for a bomber, which even allows it to fly at night.
There's two options when you're flying low altitude. One, either hand flying it, or two, what the plane was designed to is to ride in an automatic terrain following mode. And that would be our preferred mode. The computers and the coupled with the flight control system and the offensive radar can navigate the plane and fly the plane at low altitudes very, very precisely. It gives us an all-weather night capability when we can't look outside and see what's in front of us.
Let's fly a simulated mission with a B-1B to see how these features operate. The crew is on standby alert when the alarm sounds.
You see now the computer was just painting a desired flight path above the ground, and you can now see the radar terrain trace that it paints for the two pilots on their vertical situation display. You can see the terrain ahead of us is fairly flat and rolling. A few valleys out here. This is marked out in nautical miles ahead of the aircraft, with the aircraft being here. So we can see, the radar sees at least 10 miles in front of the aircraft, and we can see the terrain ahead of us 10 miles out.
The practice target is attacked using dummy bombs. At such a low altitude, the bombs have parachute retarders to prevent them from exploding underneath the aircraft. With the training mission accomplished, the B-1B heads back to base. The two officers who sit in the aft station of the B-1B bomber control the aircraft weapons and the aircraft defenses. The B-1B is heavily computerized, and their functions bear little resemblance to the classic bombers of World War II.
The pilot team are responsible for driving the aircraft, or flying the airplane, if you will, and making sure that we get to where we need to go. But for me as a navigator bombardier, offensive systems officer, my chief job is to navigate our aircraft to the target, drop our weapons, get them on target, and then get us home. Defensive systems officer, my counterpart in the aft station, he makes sure that we are able to get there. He defends the airplane against enemy threats. As a defensive systems officer on board the aircraft, I'm primarily concerned with the navigation and weapons delivery. And I'm mainly concerned with the equipment that's from the middle of the aircraft on over here to the right. I'm in charge of applying a power to the navigation equipment itself, inertial navigators, the core electronics or the core computers for the system itself, bombing and navigation, and able to update the inertial navigators as we're flying along and make sure that we're able to hit our targets. This is what we call a CNAV summary. It lists the present position of the aircraft, the time to go to our next destination, what time we're going to get there, how far away we are from it, and then parameters like what the magnetic heading is to it, what the wind velocity and vector is. And this display also lists what radar aim points are going to be left or right of the nose of the aircraft as we're coming up on them, so I can aim at them. When I get down to aiming, I use the tracking handle to move my crosshairs onto the aim point, and I know exactly what the latitude and longitude of this aim point is going to be. So if I move the crosshairs onto the aim point, I'll be able to see exactly how far my inertial navigator has drifted off from where it actually should be. Then I can update the inertial navigator by using this method, and that way we can ensure bombs on target, and that's the name of the game, is bombs on target. We have 3 weapons bays on board the aircraft, as opposed to 1 weapon bay on the B-52. Internally, the aircraft is capable of carrying up to 24 gravity nuclear weapons or short-range attack missiles or air-launched cruise missiles. That's what the aircraft is capable of carrying. That's quite a lot of ordnance in one piece, in one place. The B-52, on the other hand, can't carry nearly as much, internally that is.
Besides conventional or nuclear bombs, the B-1B can also carry 2 types of nuclear missiles, the SRAM and the air-launched cruise missile.
SRAM, the acronym for Short-Range Attack Missile. The missile itself was developed in the late 1960s, early 1970s as a weapon that bombers could use as they're ingressing to a target. One way to employ them could possibly be as you're ingressing to a target, you may want to take out enemy defenses here and there to make sure that you can get to your targets. And the short-range attack missile, we just launch the missile and it goes out and strikes those targets as we're going inbound to another release. Air-launched cruise missiles, on the other hand, are you could call them a standoff weapon, if you will. You can stand off outside of harm's way and launch the air-launched cruise missile from high altitude, and the weapon will just navigate itself to its own target.
During World War II, the main threat to bombers came from enemy fighter planes. The bombers defended themselves against enemy fighters with machine guns and could be escorted by friendly fighters. The B-52 bomber of the 1950s, like its World War II ancestors, carries a single automatic cannon in its tail. The B-1B has no guns to defend itself because the threat to bombers has changed. Since the 1960s, the main enemy of the bomber is no longer the enemy fighter, but the surface-to-air missile. Modern anti-aircraft missiles rely on radar to find the bomber and guide the missile to hit the bomber. So to defend the B-1B against the deadly missiles, it is necessary to defeat the radars that guide it. This is the task of the defensive systems officer using electronic countermeasures.
We don't have any active or any lethal defense as a gun. And the reason for that is it's really not needed. The B-1 is whole design is designed so we don't need that. Our low radar cross-section, which is approximately 1% that of the B-52 is a head-on shot, is our big advantage. The importance of low radar cross-section, especially in a penetrating bomber, is that the operator on the ground who's controlling, say, surface-to-air missiles or artillery guns trying to shoot us down, he doesn't have the ability to see us as easily as a target with a large radar cross-section. What we mean by that is on his scope, usually get a blip, let's say that generic term. Now, he won't be able to see us at all, or if he does, it'll be a small blip. Hopefully, he won't be able to pick us up at all. Therefore, if he can't see us, he can't shoot us down. And we have the low radar cross-section because we don't have any external antennas in that, and our high speed. We don't need any active or lethal defense. We do carry electronic countermeasures, which we use really as a last resort. Our main mission is to go run silent into the threat area, so they'll never see us. And that's our main mission. But if they do see us, as a last resort, we will use our electronic countermeasures for ground and air threats. We also carry expendables, chaff, and flares against infrared homing missiles.
Future generations of strategic bombers like the B-2 stealth bomber promise to be virtually invisible to enemy radar. Nearly any combat aircraft can carry bombs. Almost all fighter aircraft, from the smallest through the largest, can be fitted to carry bombs and precision-guided munitions. However, over the years, specialized attack aircraft have been developed specifically for bombing and ground attack. Tactical strike airplanes, which are armed primarily with conventional bombs and missiles, are usually called attack aircraft. The term bomber is usually reserved for much larger strategic aircraft armed with thermonuclear bombs and missiles. Attack aircraft differ in their design depending on their weapons and targets. One of the most specialized attack aircraft is the United States Air Force's A-10 Thunderbolt. The A-10 is designed specifically to attack tanks. It is armed with a powerful 30mm cannon in its nose and can also carry bombs and special precision-guided attack missiles like the Maverick. The most sophisticated attack aircraft in NATO today are the Tornado and the F-111. These aircraft have advanced computers and attack radars which allow them to precisely locate and attack targets even in bad weather or at night. Over the past decade, several new types of aircraft weapons have been developed that have revolutionized ground attack. The laser-guided bomb can home in on pinpoint targets. Guided missiles like the Maverick contain their own sophisticated target seekers that steer themselves all the way to impact. The Durandal bomb is intended to crater enemy airfields to prevent their use. Propelled by a rocket, it bores through the concrete and explodes deep underneath several seconds after impact. Cluster bombs, like the Matra Beluga, scatter their deadly munitions over a much wider area than more conventional bombs. The weapons that this team is loading into a B-1B bomber are simulated B-61 thermonuclear bombs. If these bombs were real, each would have the explosive force of 500,000 tons of high explosive, enough to destroy a small city. In peacetime, even these simulated exercises are conducted with the tightest security.
During peacetime, we treat it just like wartime. We don't treat these any different. Nuclear weapons are nuclear weapons. There's an Air Force regulation that covers that, Air Force Reg 122.4. It's called two-man concept. It's a reg that states that no individual will be alone in an area with nuclear weapons. It's very critical that you don't leave any lone individual in the area that would have the time to tamper with a nuclear weapon or the system. So they have to keep in contact with each other all the way through the load. There's 2 security policemen usually at the aircraft tail end and the nose end, and they would, if they've seen the violation, would stop the load immediately. They would take the individuals to jail.
For all the training these airmen undergo, for all the expense and time spent designing these fearsome weapons, in the end, they will probably never be used. At the heart of Strategic Air Command doctrine is the notion of deterrence. Strategic weapons like the B-1 bomber are intended to deter aggression against the United States. If the B-1 is ever actually used, the policy has failed. The crews of these aircraft are all too well aware of their awesome responsibilities.
To use an analogy, my job is similar to like being a policeman. I don't think any self-respecting policeman would get up in the morning thinking that he's going to go out and shoot a criminal that day. I'm the same way. When I go to work, I don't want to pull out my gun, so to speak, and hurt someone. We're here to deter and keep people from attacking this country, and that's what we're here to do. If deterrence were to fail, to borrow a term from the Marine Corps, no one likes to fight, but someone has to know how, and that's what we're here to do.
Well, of course, you never want to have any major war break out, especially the kind of war that would happen when we're involved with the B-1. Our mission, of course, is deterrence, but we still have to get into the books, and we really study up for the mission if we really had to do it. I think, of course, we'd be highly motivated if the horn did go off and we were launched and we knew this was going to be the big war. I think we'd be probably more motivated thinking that probably our families wouldn't be here when we got back, so we'd probably do that much of a better job. Although we'd really hate to see that ever happen. Hopefully it never will.
In an age of intercontinental ballistic missiles, the manned strategic bomber may seem like an outdated concept. Yet the manned bomber still has one very important feature. In an international crisis, the bombers can be launched and then recalled if the crisis subsides. The manned bomber serves as an important political tool to a president in time of international tension.
The biggest one, I think, in terms of national command authority is the ability to recall the bomber. Once it's launched, if a tense situation subsides, our command authority can bring us back to a base and put us back on the ground. Another real good asset of the plane is a show of force You can project it forward to forward bases, put it in the air, show an intent, where it's impossible to do that with, say, a land-based missile or a SLBM.
Future strategic bombers may look very different from today's B-1B. The United States Air Force has been developing the exotic B-2 stealth bomber. The B-2 carries the stealth features of the B-1B much further and is virtually invisible to radar. The manned bomber may no longer be the primary element of the strategic forces of the superpowers, but it is likely to remain an important element of the strategic triad into the 21st century. The dominant weapon in land warfare since the Second World War has been the tank. Today, guided anti-tank missiles are the most serious challenge to tanks on the modern battlefield. Their shaped charge warheads can bore through nearly a foot of steel armor. If they hit the tank's vulnerable ammunition, as we see here during a test firing, the results are catastrophic. Most contemporary anti-tank missiles use wire guidance. When the missile is fired, a thin wire, hardly thicker than a human hair, is spooled out behind it. The launch station automatically tracks the missile gunner keeps the launcher pointed at the target, and the guidance system in the launcher sends signals to the missile through the wire which correct its trajectory. Anti-tank missiles come in different sizes, tailored to different missions. Medium anti-tank missiles are designed for the infantry. They must be easily portable. A good example is the American Dragon anti-tank missile, which can be carried by a single infantryman. In Europe, the Euro missile Milan is the preferred anti-tank weapon for infantry. It uses a two-man crew and has an effective range of 2 kilometers. The Milan can also be fitted with a mirror night sight, which enables it to be used at night as well as in daylight. The success of weapons like these and their Soviet counterparts has led to improvements in tank protection. Tanks now use Chobham armor or reactive armor to protect against missiles. This has led to further improvements in the missiles, like tandem warheads, which can defeat reactive armor. The Swedish Bill missile uses another approach. Rather than attack the thick frontal armor of the tank, protected with layers of advanced armor and reactive armor, the Bill instead attacks the thin roof armor. It is programmed to fly over the tank, and when in the right spot, detonates its warhead downward with dramatic effect. Conditions on a possible European battlefield have led to other specialized approaches, such as the new Aerospatiale Eryx missile. Because of their speed, medium anti-tank missiles cannot be guided for the first few hundred meters of their flight, so they cannot be used at close ranges, such as in city fighting.
C'est un missile pour le combat urbain.
This is an urban combat missile which can be fired from enclosed spaces. It leaves with a very slow speed, and its guidance system allows it to maneuver at short ranges. The infantryman can launch it while in towns without worrying about the backblast, like the type that would come from a high-speed missile.
Besides the portable medium-range missiles used by the infantry, there are also heavy, long-range anti-tank missiles. These missiles can hit with pinpoint accuracy at ranges over 3 miles. The best known of these is the American tow missile. The TOW is mounted on armored vehicles and on helicopters. The TOW can also be fired from armored vehicles like the M2 Bradley infantry fighting vehicle. In Europe, the counterpart of the TOW is the Euromissile HOT. As in the case of the TOW, it can be fired from both armored vehicles and helicopters. The laser-guided Hellfire missile supplements wire-guided anti-tank missiles like the TOW. The Hellfire was specifically designed for use from helicopters like the U.S. Army Apache. It is the most powerful anti-tank missile in service today and can hit targets over 6 miles away. The Hellfire is laser-guided. The Apache weapons operator aims a laser designator at the target, and the missile homes in on laser light reflecting off the target. Future generations of heavy anti-tank missiles will not need wire or laser guidance links, but will use advanced seekers which automatically home in on the target. Another unique guidance system being developed for anti-tank missiles is fiber optic guidance. The missile trails an optical fiber which conveys the video image from the camera in the nose of the missile back to the operator. The operator can actually see the same video image of the target seen by the missile. The operator can steer the missile into the target with great precision. This will permit the development of missiles which can strike targets at much greater ranges than now possible, perhaps as far as 30 miles away. These missiles could also be used to attack low-flying helicopters. There are 2 such missiles in development, the FOG-M in the United States and the Polyfem in France and Germany. Another way to attack land targets is with ballistic missile artillery. The United States Army's MLRS artillery rocket system can attack concentrations of tanks and other targets using small, scatterable bomblets. The new Army TACMS has greater range and a greater payload. Future versions of MLRS and TACMS will carry guided submunitions able to hunt out tanks with pinpoint accuracy. For a century, the traditional weapons of naval warfare have been the gun and the torpedo. But with the advent of miniature radar guidance seekers and advanced electronics, anti-ship missiles are joining the naval arsenal. Perhaps the most famous of these is the French Exocet. Weapons like the Exocet can be fired from surface ships, aircraft, or even submarines. Its American counterpart is the Harpoon. This type of anti-ship missile contains a small radar in its nose. After launch, they are programmed to skim over the sea at very low altitude so that enemy ship radars cannot detect them. Their radar seekers identify the target and steer the missile for precise impact. The sophisticated guidance in the Harpoon permits a wide range of tactics. The missile can be programmed to fly over or around obstructions like small islands. They can also be programmed to fly a false heading, luring their intended victim into thinking that they are aimed at a different target. At the last moment, they change their course. Submarines have traditionally relied on torpedoes to attack surface warships, but now they can also fire anti-ship missiles from underwater.
The main weapon to attack a surface ship is a torpedo. Increasingly now you're also seeing submarine-launched missiles, like the French Exocet, the American Harpoon, There are a variety of Russian missiles, SSN-7, SSN-3 to some extent, where the submarine can stand off at a greater distance and fire.
Submarines can also fire specialized anti-submarine missiles like Sea Lance. Sea Lance is a rocket-propelled torpedo. It is launched like a missile and has the speed and range of a missile. But when near the target, it releases a torpedo into the water to seek out a hidden submarine. Anti-ship missiles can also be fired from a variety of launchers. The British Sea Skua, for example, is small enough to be carried by a small naval helicopter. The Franco-Italian Automat missile can be fired from a ship, but also from coastal defense launchers to protect harbors from enemy ships. The Soviet Navy is best known for its very large anti-ship missiles, which are nearly the size of a jet fighter. The massive tubes on the front of this Slava-class cruiser contain 4 SSN-12 Sandbox anti-ship missiles. They are intended to attack large surface warships like aircraft carriers. Future generations of anti-ship missiles are likely to be supersonic, making it far more difficult for a ship to evade them. An aerospatiale official describes such a missile, the new ANS.
Its
advantage resides essentially in the missile's capacity to avoid enemy defenses. It benefits from a high degree of stealth features, by an ability to defeat countermeasures, and finally, by supersonic speed. In fact, more than Mach 2.
Naval missiles can also be used to attack land targets. The U.S. Navy's Tomahawk cruise missile uses a special guidance system called TERCOM to seek out land targets. The missile's computer contains a map of the target area, and it compares the radar images of the terrain below it with the computer maps stored in its memory. This allows precise attacks against pinpoint targets miles inland. These targets can also be attacked with special submunition warheads, which scatter a large number of small bomblets over a wide target area. Missile-armed attack aircraft and combat helicopters pose an especially serious threat to ground forces. Not surprisingly, armies have turned to missiles to defend themselves against the air threat. Air defense missiles come in many sizes, from short-range systems that can be carried by an infantryman, like the Javelin, through highly complex systems that can hit enemy aircraft 40 miles away, like the Hawk. The first man-portable air defense missile was the U.S. Army's Red Eye, developed in the late 1950s. It has been replaced by the new Stinger missile. The Stinger uses a sensitive infrared seeker that picks up the heat given off by modern attack aircraft. It has a maximum range over 3 kilometers. The effectiveness of the Stinger was clearly demonstrated during the war in Afghanistan. The noted defense analyst David Isby traveled with the Mujahideen resistance during the war and explains the Stinger's importance.
Starting in 1986, these were supplied to the Afghan resistance, and they have been used, it appears, most effectively. According to U.S. government sources, no less than 68% of those fired have resulted in shot down Soviet airplanes or helicopters. In the June 1987 Soviet offensive in Paktia province, which is one of the areas where there's been the most intense fighting in Afghanistan, the Soviets have had to reduce the use of helicopter gunships, which up until now have been their primary offensive weapon in Afghanistan.
The Stinger can also provide fast, mobile air protection night as well as day. The United States Army uses a pedestal-mounted Stinger called the Avenger. The French Army's new Mistral missile is similar and also uses infrared guidance.
The Mistral is a short-range infrared missile, about 7 kilometers in range. In our view, it is the most advanced system in the world today. It has been in service since the end of 1988. It is used by 6 countries, and we estimate 10 uses by 1990.
Another missile used in Afghanistan was the British Army's Javelin. The Javelin uses a different guidance system from the Stinger or the Mistral. The missile crewman places a small cursor over the target using a finger control, and the missile is automatically steered against the target. The British Army is currently developing an even more sophisticated successor to the Javelin called the Star Streak. A third approach in man-portable missile guidance is found in the Swedish RBS-70 missile. The RBS-70 operator directs an invisible laser beam against the enemy aircraft, and the missile rides along the beam into the target. To protect maneuver forces against aircraft, air defense missiles are mounted on tracked vehicles. The Chaparral is a medium-range missile system used by the U.S. Army. The missile itself is derived from the famous Sidewinder dogfighting missile. It uses infrared homing like the smaller Stinger. The U.S. Army is now developing a successor, the ADATS, as part of its Forward Area Air Defense Program. The ADATS uses new laser guidance technology. Modern attack helicopters are now employing infrared flares to confuse heat-seeking missiles. As is apparent here, they do not confuse a laser-guided missile. European armies have favored radar-guided missiles. The Crotal is used for air-base protection, and it has been widely exported. The German and French armies use the radar-guided Roland missile system. A senior Roland program engineer describes the current effort.
Roland système se trouve actuellement en fabrication de grande série.
The Roland is now in service with 10 countries, 3 of them in NATO. There are 540 launch systems and about 25,000 missiles in service today. It is an air defense system to protect against low and very low altitude aircraft. Originally, it was designed to escort mechanized formations, and its use has been extended to defend fixed sites, such as command posts and airfields. It is being modernized both for the French and German armies.
Air defense missiles for high-altitude protection are the most sophisticated variety of anti-aircraft missiles. The most widely used missile of this type is the Hawk, first developed for the United States Army in the 1950s. It has been continually upgraded, and the most advanced version is called the Hawk Phase 3. The Hawk system includes long-range surveillance radars to locate and identify enemy aircraft, and illumination radars, which are used to guide the missile to its target. Although the Hawk is designed primarily to intercept aircraft, as early as 1960 it demonstrated its capacity to engage even tactical ballistic missiles. The Patriot system is the successor to the Hawk. Patriot is the most effective high-altitude tactical air defense missile system in the world today. As missiles become more sophisticated, electronics form a greater and greater portion of the whole system. Patriot is centered around a phased array radar. Unlike conventional radars, which rotate while searching, the phased array radar steers its beams electronically. The Patriot's phased array radar can track up to 100 targets and control up to 5 missiles simultaneously, a considerable improvement over the older radar guidance systems. The radar sends out a special electronic signal that illuminates the targeted aircraft. Then it tells the missile to open up its receiver and pick up the reflected energy. When the missile receives the reflected signals, it reports back to the main radar, telling it what energy it sees. The computer then sends course corrections to the missile via the radar to ensure a very precise interception. Although this track-by-a-missile guidance method is extremely complex, it makes it nearly impossible for an enemy aircraft to jam the missile guidance system using electronic warfare equipment. Over the past 2 decades, the role of missiles in modern armed forces has continued to grow. Missiles are now an essential ingredient in a whole range of modern weapons, including combat aircraft, warships, and armored vehicles. High-tech missiles give today's soldiers the critical combat edge on the battlefield. There are many Marine forces around the globe. Britain has its famed Royal Marines, and the Soviets field a sizable naval infantry branch. But the United States Marine Corps is the largest of these and the best equipped. For centuries, navies have had small marine forces for protecting their ships and carrying out raids against enemy positions on the shore. The importance of the United States Marine Corps grew tremendously during World War II. Highly trained troops, supported by specialized equipment, were needed to wrest control of many Pacific islands from the tenacious Japanese defenders. Battles like Tarawa and Iwo Jima became the stuff of legend. They ensured the Marine Corps a vital place in America's armed forces. Today's United States Marine Corps is designed for mobility. Their doctrine and equipment allow a Marine Air-Ground Task Force to be deployed to trouble spots around the globe at a moment's notice. This program examines the types of modern equipment used by the United States Navy and Marine Corps to carry out expeditionary missions, especially amphibious assaults. The weapons used to project marine power ashore have changed since World War II. Amphibious assault vessels are more capable than their World War II ancestors. New types of specialized Navy amphibious assault ships, like the Tarawa class, provide a sophisticated mix of naval and air support. And the advent of the helicopter provides a critical addition to battlefield mobility.
Well, obviously, the operations of World War II were restricted to certain types of surface assault craft embarked from a vessel. Now we have that capability in addition to the air assault, heliborne assault capability, which greatly enhances our strike profile and allows us to a wider variety of missions in support of the amphibious landing ashore.
Even with its sophisticated new hardware, at the heart of the Marine Corps is its superb light infantry. The weaponry of the Marine soldier is designed for portability. The Marine rifleman is equipped with an M16A2 assault rifle. This is an improved version of the M16 rifle first used in combat 20 years ago in the Vietnam War. The M16 rifle can also be fitted with a 40mm M203 grenade launcher. Fire support for the rifle squad and platoon is provided by the M249 5.56mm machine gun and the heavier M60 7.62mm machine gun. These can be supplemented by the Mark 19 40mm automatic grenade launcher seen here mounted on the Humvee vehicle. Marine rifle companies receive additional fire support from lightweight 60mm mortars like these. Tanks are a constant danger to infantry on the modern battlefield, and the Marines use the man-portable Dragon-guided anti-tank missile and also the vehicle-mounted tow missile launcher to knock out enemy tanks. For defense against enemy aircraft and helicopters, the Marines use the Stinger man-portable missile. The Stinger was first used in combat by the Afghan resistance in 1986 and has proved to be highly effective, even against sophisticated jet attack aircraft. The Marines are not as heavily mechanized as their Army counterparts, but they do have tank support in the form of these M60 tanks with special reactive armor. The nimble LAV-wheeled armored vehicle is used for fast scouting operations. The LAV is typical of the Marines' accent on strategic mobility. It is light enough to be rapidly deployed from the air, slung under the belly of a CH-53E helicopter. These Marine weapons are not substantially different from those used by Army units. It is not so much equipment that distinguishes the Marines, it is their training and organization.
Marines pride themselves in discipline and operational readiness. We train probably harder than anybody else. People probably argue with that, but I'd say it's true from my personal experience. Also, the Marine Corps has an air side, we have a support side, and we have a ground side. So we have everything all combined in one. We don't have to request support from any of the other branches of the service except for the Navy to get us there. And once we're there, we're able to conduct operations for, well, 30 days ashore without resupply. So we're self-contained. And when you put Marines ashore, you know that they're able to do the job until further forces can come on and reinforce them. So I guess you'd have to say that our all-around capabilities are what really makes the Marine Corps different from other branches of the service.
The one armored vehicle unique to the Marine Corps is the amphibious assault vehicle traditionally called Amtrak. Amtraks were developed in the late 1930s and were first used in combat by the Marines during the Pacific battles of World War II. Their unique mobility in both water and on land made them an invaluable ingredient in the amphibious assaults in the Central Pacific. The design of Amtraks has evolved over the past 50 years. The first Amtraks, like the LVT-1, used at the Battle of Tarawa, had no overhead armor. Post-war designs like the LVT-3C used in Korea and the later LVT-P5 had more powerful engines and better armor protection. The LVTP-5 saw combat duty during the Vietnam War. The latest design of Amtrak's, the AAV-7, features full armor protection and has much superior mobility in water and on land than any previous amphibious assault vehicle. Amphibious assault vehicles form the first wave of any contested beach assault. They have many advantages over conventional landing craft. They are armored, so they protect their troops against machine gun and artillery fire. And their tracked suspension allows them to operate over reefs and other beach obstructions which would stop a landing craft. They give the Marines mobility beyond the beach as well.
The AAV-P7A1 and its two other variants, the command vehicle, the C7, and the recovery vehicle, the R7, provide the Marine Corps an amphibious mechanized assault element from the ship to the shore, and then to conduct further mechanized operations ashore in pursuit of the landing force objectives. The AAV-P7A1 is designed to carry 25 combat-equipped Marines. In actuality, the best number it can carry is 18. It's armed with the M85 50 caliber machine gun, or with a new upgun weapon station, an M-Deuce 50 caliber machine gun, and a Mark 19 automatic grenade gun. It's armored with aluminum alloy armor, designed to resist artillery fragmentation and 7.62 armor-piercing round.
The AAV-7 swimming ability comes from its boat-like hull and special water jet propulsion system. The water jet draws in water from above the track and expels it out the rear. These jets can be steered by the driver to turn the amphibious assault vehicle while in the water. They give the vehicle a speed of 8 miles per hour in the water. The special watertight hull allows it to operate in 10-foot swells. On shore, the amphibious assault vehicle serves as an armored troop carrier. This unique versatility, both on land and in the water, makes it the invaluable tool in amphibious operations. It is able to transport troops inland at speeds up to 45 miles per hour under armored protection. The AAV-7 was originally armed with a turret-mounted 50 caliber machine gun, and they are currently being modernized with an upgunned weapon station with an additional 40-millimeter grenade launcher.
The armament of it is the upgraded upgun weapon station. It's got a 40-millimeter grenade launcher with a M-Deuce 50 caliber machine gun, which really does put down a lot of firepower compared to a few years ago.
The essential naval ingredient in amphibious operations is the amphibious assault ship. Since World War II, the United States Navy has developed a range of sophisticated warships specifically for amphibious operations. Among the largest and most capable of these are the amphibious assault ships such as the USS Saipan, a member of the Tarawa class of amphibious assault ships.
Saipan in an amphibious operation plays a very central role because she has most of the forces. We have all the helicopters and the Harriers, and we would have the greatest majority of the troops. And so the troops would go ashore by helicopter from our deck or by boat through our well deck.
On first glance, ships like the Saipan resemble regular aircraft carriers. In fact, there are substantial differences.
The biggest difference between the LHA and the The regular aircraft carrier as we know it are the catapults and arresting gear. We don't have catapults and arresting gear. We cannot operate conventional fixed-wing aircraft. So you can look across at the other ship here and see they have the catapults and arresting gear, and that's what enables them to operate conventional fixed-wing aircraft, and we can't do that.
The Saipan carries aircraft and helicopters that directly support marine operations. This includes transport helicopters and Harrier vertical takeoff jets.
The Saipan is an amphibious assault ship, so the marine aircraft are aboard basically to transport the Marines and to assault the beach. So there are 3 or 4 different types of helicopters. There's the Cobra, which is the attack gunship, and will provide cover for the other helicopters that run in with all the troops. We have H-46, the 2 main rotor type helicopters. We have H-53, a big Sikorsky helicopter, which carries a lot of troops in. Normal complement would probably be 10 big 53 helicopters, maybe another 8 or 10 46 helicopters, and 6 or 7 Cobra gunships, and then a normal Huey H-1 command control and gunship. All of these come on here, and as you can see, we only have 8 spots. So normally the aircraft are staggered and parked around the deck. During an amphibious launch, we have all the Marines in sticks and lined up underneath the deck here. We move the aircraft on spot. They turn up once they're ready to go. We give the high sign. The people bring the troops on. They're loaded in the aircraft, and they're gone in 5 minutes. As soon as they're leaving, the other people are already hooked up with tractors to the second wave of aircraft, and they're pulling them out. It's really fast-paced. They come in, the aircraft come back and refuel. We refuel them in 10, 15 minutes, load more troops, and they're gone.
But the Saipan is more than just a mini aircraft carrier. Its motto is Omnia Facimus. We do it all. The Saipan and her sister ships of the Tarawa class also have a large well deck at the stern, which allows them to land and embark landing craft which bring supplies and troops to the beach. Inside her cavernous hull are storage facilities for the supplies needed to conduct an amphibious landing. In the event of casualties, the Saipan has extensive medical facilities.
We have, next to the hospital ship, the largest and most complete medical facilities afloat. 4 operating theaters and a 48-bed ward, plus an intensive care unit of about 20 beds and an overflow for recovery of some 300 beds. So we have about a 350-bed hospital in this ship. That's really an extensive capability.
Supporting ships like the Saipan are the smaller amphibious transport docks, the LPDs, and the dock landing ships like LSD-37 Portland.
The USS Portland is an LSD, landing ship dock. It's a misnomer in a way because the Portland is not a landing ship. We don't actually land, but we carry organic boats that do land on the beach. We also have helo capabilities, platform for launching helos. Our main mission is to support the Marines in getting them to the beach, be helicopter or assault craft, or in the cases we have today, the AAVs.
The entire stern of the LSD is filled with a large well deck, which acts as a miniature harbor. It can contain 50 amphibious assault vehicles or various assortments of landing craft.
We have a well deck that is capable of ballasting down and bringing water into the well so we can bring assault boats or landing craft inside our well. So we can either be dry or wet, depending on what our mission is and what we're loading. Or we can be a combination of that. We can have partly a dry well and partly a wet well. What we do is we have a number of ballast tanks, 44 of them to be exact, and we fill these with water, and it ballasts the ship down. We open our stern gate and flood our well deck, so to speak. This well deck is 422 feet long and 48 feet wide. In the case of the AAVs, we would ballast down to about 2 foot over the sill to bring the AAVs into our well, we bring them all the way into a dry deck and position them in the forward part of the ship all the way back.
For the Marine Corps, these amphibious assault ships offer versatility, well suited to the complex demands of amphibious operations.
One reason I like the landing platform dock is that I have several options of how to get my Marines off the ship and onto the shore. I can take them out by boat through the well. I can take them out by assault amphibious vehicle, or I can take them off by helicopter. That gives me 3 good choices right there. And I can do those all at the same time if I have to.
The Navy still uses landing craft to bring supplies ashore. But the main innovation in supplying the beach assault is the air cushion landing craft, called the LCAC, for Landing Craft Air Cushion. The LCAC's propulsion system creates a pillow of air underneath the main platform. The air pillow is contained by special skirts around its edge. Forward propulsion comes from a pair of large propellers at the stern of the craft. The LCAC has several advantages over conventional landing craft. Riding on a cushion of air, it is 5 times faster than a normal craft, over 50 miles an hour in calm seas. In addition, the LCAC can bring the supplies right onto the beach. The LCAC can carry 60 tons of supplies, even including tanks. The sophisticated controls of the LCAC are closer to that of a jet aircraft than a conventional ship. The LCAC can be used in conjunction with the Navy's amphibious warfare ships. During long sea voyages, the LCACs are nestled inside the well docks of the mothership.